This is lesson 25 of Algebra 1. We're on page 106, and we're talking about the solution of equations. And we've been talking about how you can add to both sides of the equation, or subtract, or multiply, or divide, as long as you do the same thing from on the left side and the right side when you're working through a problem. You should be able to maintain a true statement and solve for an equation. Okay, so before we were just either adding or subtracting, or we were multiplying or dividing. This one is going to be a multi-step solution that you're going to need to take. So we have 4x plus 5 equals 17 as our first example. This is example 25.1, page 106. Okay, so we are going to look at our x and say, okay, we want our x on one side of the equation and everything else on the other, because we want it to say x equals something. We want to solve for x. So we're going to first get rid of the 5 by subtracting it, because you do the opposite of whatever is happening right here, because a positive 5 minus 5 is 0, and 0 plus 4x is still 4x. 4x equals 12. Okay, so now we need to say 4 times what is 12? Well, if I divide both sides, 4 divided by 4 is 1, so we get x. 12 divided by 4 is 3. X equals 3. Oh, I'm sorry, I wasn't following that very well. So x equals 3. Let me get another example for you. All right, negative 7k minus 4 equals negative 21. We're solving for k. We want k to be by itself, so we're going to focus on getting rid of this first by adding it to both sides. Negative 7k equals, let's see, 21, a negative 21 and a positive 4, two different signs. You subtract, and what do we get? 17. And it's negative because the negative is in front of the 21, and the 21 is the bigger number. We divide both sides by negative 7. Negative 7 divided by negative 7 is 1. 1 times k is k. A negative divided by a negative is going to give me a positive answer. So the answer should be k equals 17/7. Now we've got an example from your practice questions. This is practice question A on page 108. 2/5 x minus 3/10 equals 1/2. First thing I'm going to do is I'm going to make the denominators all the same. This should be 4/10 x, and this should be 5/10. We've already worked kind of through how to do that, how to change our fractions into common denominators. Okay, so now that we have common denominators, I'm just going to solve for it. I want x by itself, so I'm going to get rid of this 3/10 first. This is 4/10 x equaling 8/10. Okay, hopefully you're with me so far. 5/10 plus 3/10 is 8/10. This drops down here because this disappeared. I'm going to use my reciprocal to take this times this. Okay, so 10 divided by 10 is 1. 4 divided by 4 is 1. 1 times 1 is 1. 1 times x is x. Okay, so we have x on this side. Finally, x is going to equal something. 10 divided by 10 is 1. 8 divided by 4 is 2. We keep the 2 on the numerator because this is where it needs to be. The 8 is not down here, so 8 divided by 4 is 2. So 2 times 1 is 2. X should be 2. So sometimes we can do the same kind of equations and we're working with decimals. We've already worked with regular whole numbers, we've worked with fractions, and now we're working with decimal numbers. So I am going to do the same thing as I've done any other times. I'm going to isolate my x, get it all by itself. That becomes 0. And this becomes 56 hundredths. Okay, I can divide and divide. X is going to equal 8. I think it's actually 8 tenths. Okay, so that's how you solve for that equation.